Proof and usage of complete differentiation using partial differentiation. Yeah. In this video, we are basically going to differentiate complex expressions in x and y. Let's say like this. We are differentiating such expressions by using partial derivatives. And it's necessary to know what partial derivatives are. This is partial derivative with respect to x. This is partial derivative of function with respect to y, and this is just derivative of y with respect to x. So basically, let me clear that before we start. So let's say if we have to differentiate with respect to x for, let's say, 3x square y square. For this, if I'm differentiating with respect to x, I will use product rule, and both of them will be variable. Yeah. Now if we differentiate x square, that will be 2x. Yeah. In y square, and then now if I differentiate y square, that will be 2y, but this is with respect to x, so using chain rule we should also have dy by dx. So this is the complete differentiation. Yeah, but if it was partial differentiation with respect to x, then all the other variables except x will be constant, so y square will be constant. So 3y square will be as it is, and x will be differentiated, so 2x. This will be the answer. Yeah. Similarly, if we have d dx of y square, this will just be 0 because this is a constant. But if we had complete differentiation of y square, this will be 2y times dy by dx. Yeah. So this is the difference between complete derivative, partial derivative. For complete derivative, this should still be a variable, and we need to use chain rule. For partial derivative, all other things will be just constant, and they will act as constant. That is it. Now, since we know about, and this just represents a derivative of function with respect to x, and this represents derivative of function with respect to y. That is it. Now let's move forward. So let's say, let's say we have this function. We have this function xy comma 0 equals to 0. Now if we take differentials in both the side, if we try to take differentials in both the side, this will just be df partial derivative with respect to dx, and then dx plus again partial derivative with respect to dy times dy. So this will get in this form. Yeah, basically with dx we will just have partial derivatives of f with respect to x, and with dy we will just have partial derivative of f with respect to y, and this will be 0. So if you want to look at how if that is true or not. So let's say we have x square y cube equals to 0. Yeah. Now we will have 2x. We will have 2x, and then y cube plus we will have, if I'm taking just differentials, so in that case I will also have 2x dx. Okay, and then I will have x square times 3y square dy. Now you can notice that 2x y cube is just the partial derivative of this function. Yeah, with respect to x. Now again, this is also just the partial derivative of the function with respect to y. So you can see easily that this is just partial derivative of function with respect to x. Then we have dx plus this is just partial derivative of function with respect to y, and then we have dy. This is basically just a property for taking a function with 2 parameters. If there are 3 parameters, we will also have partial derivative f with respect to z, and then dz. So this is a property, let's say. And so now if we use this property, we can take this to other side. Partial derivative of f with respect to x dx will be minus partial derivative of f with respect to y times dy. Now we are already at the end of the proof. So df by dx by minus df by dy, and this will be dy by dx. That's why dy by dx equals to negative of that is partial derivative with respect to x by partial derivative with respect to y. This was the statement, yeah? Yeah, this was the statement. Now let us use this statement to prove some of the to find differentials in some of the problems. Let's say our problem is, let's say it's kind of complicated, and our problem is something like this. It's x square y plus e to the power x sin y. Now if it's something like this, and is equals to 0. Now if we try to differentiate implicitly, it will be a lot long. Yeah, we will have dy by dx, and also differentiate this. There will be so many plus minus, and we have to take it to other sides, and those first thing will be there. But if we have to find dy by dx directly, we can just use the formula minus partial derivative of f with respect to x, and this whole function is f. Yeah, so whole function is f by df by dy. You can just use that. And now this is easy. Df by dx will be 2xy plus e to the power x sin y, and df by dy will be x square plus e to the power x cos y. See, we get answer in one step. So it's really easy to find derivative in this way. Yeah, and I hope you will use this to solve other problems too, and you will enjoy using this method, or let's say property, or anything like that. So solve other problems, enjoy this technique and idea. Thanks for watching, and look forward to seeing you in the upcoming videos.